In this video, we're going to look at how to find the volume of solids generated when we rotate the area underneath the curve about the x-axis using integration. For our example, we're going to be finding the volume of the solid generated when the area between the curve y is equal to root x, the x-axis, and the line x is equal to 2 is rotated about the x-axis. This is what the curve y is equal to the square root of x looks like. And the region we are interested in is between the curve, the x-axis, and the line x is equal to 2. So it's this highlighted region here. If we rotate this region about the x-axis, then the solid that we're going to generate is going to look something like this. We can think of this solid as being made up of a series of cylindrical discs, so that if we are able to find the volume of each cylindrical disc and add them up, we should then have the volume of this solid. Now recall that the volume of a cylinder is given by the formula pi r squared h. We're going to apply this formula to find the volume of one cylindrical disc. So for a cylindrical disc, instead of the radius r, we're going to replace it with y, because the radius of each cylindrical disc is going to be given by the y value of the function corresponding to a given value of x. Instead of the height h, we're going to replace that with dx, a very small increment in x, dx, so that the volume of each cylindrical disc is simply going to be given by pi y squared dx. In order to find the volume of the solid, what we're going to have to do is sum these up, which is equivalent to taking the integral from 0 to 2 in this case of pi y squared dx. Now that we've established the formula for the volume of the solid, our next step is to do the integration. First, we're going to need to replace the variable y and express it in terms of x using the definition y is equal to root x, so that the volume becomes pi times the integral from 0 to 2. Replacing the y with the square root of x, we get root x squared dx, and this simplifies to pi times integral from 0 to 2 x dx. This gives us pi times x squared on 2, going from 0 to 2. Taking out the 2, we're going to get pi over 2 times x squared going from 0 to 2. And sub in the limits, we're going to get pi on 2 times 2 squared minus 0 squared, which is equal to pi on 2 times 4. So our final answer, the volume, is equal to 2 pi units cubed. Thanks everyone for watching the video. In our next video, we're going to look at how to find the volume of solids of revolution, but this time rotating about the y-axis. So make sure to subscribe and stay tuned. We'll see you in the next one. Bye for now.